Welcome back to Made Up of Wires, where we may soon be decompiling SNK Arcade Classics. That one might not be a joke, but today we're going to be decompiling Castlevania Symphony of the Night. I'm feeling a little lost. I finished off what I think is a reasonable set of the data in Doppleganger 10 and 40. The last functions are out. Hey, dig down deep. Good to have you. The last functions are out for PR right now, and then I'm going to submit another PR with all the data that's been imported. I might go back at some point and try to consolidate a lot of the code, because a lot of the code is the same between the two. But doing that will involve resolving symbols and other things that may or may not be work. So, excuse me. We'll see if that is to be done. If you are new, haven't been watching, we've been decompiling Doppleganger 10 and 40, and like I said, the last three functions in those two overlays are out for PR. Had a few just small nits that I needed to fix. So now what is next? We could go back to Sword. We were working on Sword for a while. That kind of stalled the functions remaining there. Had some issues that I couldn't resolve. I think what I'm going to try to do, and this may go spectacularly bad, but we'll see how it goes. We don't have main for PSP done, and I have kind of maintained my working theory was that to get Symphony of the Night onto Xbox 360, Konami may or may not have had to write a compatibility layer for the game that emulated or re-implemented the PlayStation 1 SDK. And then that PS1 SDK implementation is what we see quite frequently in the PSP version of the game as well. Are those the same? Are those different? Was there some other middleware that was used for Xbox 360? We don't know. But we do have a bunch of infrastructure for building PSP overlays. And so what if we set up an overlay for main? So I think that's what I'm going to start with. This is going to be somewhat greenfield. We have a lot of infrastructure in place for stages, which there's a lot of servants, bosses, not weapons yet on PSP. Weapons on PSP is going to be interesting. We could look at that as well. But not for the main entry point, which is going to be unique in a lot of ways. So maybe we'll get started with that. Other things, go to soten.z.dev to learn more. Actually, there is one more thing that I think is worth discussing, and let me see if I can find that link real quickly. And if I was smart, I would also include that in the notes for the show. Let me see if I can. I did start excuse me. I did start making show notes. Not consistent about keeping them though. So let's make a new one. So this is the 26th. Xeeyanamo did a talk at the PSP Homebrew I don't know what it is. What do you call the PSP Homebrew? Let's see what they call themselves. Where did it go? Oh, I'm in the wrong YouTube profile. That happens. But this is on YouTube, and I will post a link to it. Give me 1 second. while I get my affairs in order. This one is not signed into the right profile either. What is happening? If you want more Symphony of the Night Decompilation content, twitch.tv/madeupofwires. YouTube, Made Up of Wires there as well. Yeah, the Homebrew, PSP Homebrew Developer Conference, that's it. Let me post a link. I will show this here as well. And so he's talking about, obviously, matching decompilation, some of the work that we've been able to do. Because we have decompiled a bunch of stuff. Let me back up and get to his segment. Obviously, the Maria work, the tooling that's used, a lot of good stuff. So this is at, I think it starts at about the 53-minute mark or so. No, right at the 1 hour mark of this PSP Homebrew Developer Conference. So definitely check that out and hear from Xeeyanamo himself. Very cool stuff. The other thing, oh, look at that, the sword. Sword familiar. The other thing that so I've been working on two things, kind of in trying to figure out what I want to do next. The first was looking at some of the mismatches for HD, and there's some odd things, and I'm still not sure what is going on in HD, but it looks like there might be another instance of a structure that's offset by an additional 4 bytes after the first pointer, and so I may want to look at that if this other PSP thing doesn't go anywhere. As I was looking at that, I noticed we have linting for removing orphan symbols, and that wasn't working. And we have a lot of symbols that are defined and not necessary. Lots and lots and lots. And so this is when we finally come back and remove them, we get a nice diff. How many, does it tell me how much? Yeah, 1,600 deletions for 45 editions. That's a pretty good ratio. That's the kind of commit I like to see. So a couple things. We weren't removing orphans at all on PSP. So I added that. But because of the way the matchings directory works, all of the symbols that we have defined were always showing up in the matchings directory of the assembly, and that's how we determine what symbols. Well, the assembly is how we determine which symbols. I shouldn't say we. Sozu D wrote this. So going through the assembly, finding symbol-looking strings, and then deleting, or creating a set of the ones that are used, deleting the ones that aren't used. So when the matchings directory started being created by Splat, all of the symbols that we had in our symbol files were always in matchings as well, and so there was always a reference to them. And so basically the change of the script was to ignore the matchings directory. Pretty simple. But then I ran into something different. There was a few things that are notable. But it was all these symbols in the bat familiar. And what's interesting about these, they're prefixed with a S. This looks like a Polish notation for static. I'm not a fan of Polish notation, but not mine to say, I guess. And what's interesting about these is these are all BSS globals. BSS is used for uninitialized data. What we see on the PlayStation is at the end of every file is a big chunk of zeros. Everything is zeroed out, and that way the game logic itself can load this binary in and just loads data from the disk. But it's actually kind of inefficient because loading data from the disk is much more expensive than just zeroing out all of the data. And so if it could exclude BSS and just zero out everything after that overlay is loaded up to the end of the address space that overlay is allowed, that actually would be more efficient and would reduce load times a little, not significantly, but a little. But that's exactly what's happening for the servants. We don't actually have any data in the bin overlay, the bin file that's on the disk for BSS. The overlay's loaded, and that is what interested me in looking at the main entry point for the PSP, because we don't have any of those functions for loading data from the disk or anything like that. So does this actually load the overlay and then zero out everything afterwards? Or does it load the overlay and leave all that uninitialized data as uninitialized, which would be against the C spec? So I wanted to find that, but to get to that information, we have, excuse me, more work to do. So I think that's what I'll go forward with. There's a few other things that may or may not be worth talking about. We have these files that are not referenced by Splat at all. And should they be? Maybe, I don't know. They are these undefined sims files, and these are for symbols that we want addresses for at link time, but there aren't actually any variables that define those things. And so main game, for example, this is the DRA address, the start of the DRA address space. And really we should have one of these variables for each of the different address spaces. Right now we have some macros defined with those values in code. I think it'd be a lot nicer if we stuck those addresses here, and then we had a symbol that we could reference in code and not have to change the macro definition at compile time. So yeah, the BSS thing, the way I got around that was by adding a new attribute. This is not an attribute recognized by Splat, but Splat will ignore it. I call it used to indicate these are used. I think I might change that, and I suggested that in the PR, that like unallocated BSS might be a better name for that. We'll see what others think. But let's go. So this stream is going to be exploratory. There are, hey Blue Harvey, there are, isn't it called Polish notation? I think it is. That's what it was called when I was in school. Maybe that's racist or sexist or one of those ists now, and I can't say that. It's not reverse Polish notation. Hungarian notation, not, that's it. It's Hungarian. Sorry, people of Poland. I should have been deriding the people of Hungary. Not Turkey or Chile, just Hungary. A lot would be, would benefit if Turkey and Chile would just get along with Hungary. Yeah. Hungarian notation, whatever. You know. So, I still have this cough. Can't get rid of it. Taking lots of decongestants, trying to get rid of it. I'm not sick, I just have a cough. It sucks. So excuse me while I blow out my microphone every 5 or 10 minutes. All right, so what we're going to do is use a bunch of tools that maybe you're familiar with, maybe you're not familiar with. I think I have a good idea of where I'm headed, but we don't know. Where we're going, there are no roads. So let's get started. The first thing I did was I wanted to see what in the PlayStation version of main, we have a nice main C, and there's a very clear loading of DRA bin, and that is really nice. We load the bin file, and that's it. And some of this is for like debugging, and those files don't exist. But for the most part, this is what we do. We look for the file on the CD. So CD search file is just moving the laser to that file on disk, and then it's going to read, and it's going to write all of that data to memory and periodically check to see where that is. And that's how the bin file gets loaded, the dra.bin at the beginning of the game. dra.bin, then that's the main game engine, and that goes and loads the save select screen at the beginning, and that save select screen is actually a stage. The stages will call back into functions that are defined in that DRA bin. So what I'm looking for is the equivalent to this main function, but on the PSP. So I'm going to do a couple things. I think looking for the dra.bin string is helpful, but it might not be there. Looking for the main symbol, it may be called main. I'm less familiar with how the PSP loads. So like I said, we're going to explore, and we'll see if we learn anything, and maybe we'll learn something together. So if we look at the structure of the UMD disk for the PSP, and this would be the same, I would imagine it would be the same if you were using like a digital version that you downloaded on the Vita or PSP as well. It's probably a disk image, I'm guessing. These are unlike the CDs where you're going directly using BIOS CD functions to navigate the file system. My impression is that for the PSP, they mount it as a file system, and then you can treat it like such. I don't know that that's true. That's my mental model of how this works. We don't have to worry about anything here. UMD data.bin, we can look at that. Let's use strings for that. It tells you some things like what is this like game ID that looks like a UPC maybe, and some other data there, what region it's for. So not what we're looking for yet. So we go into the PSP game directory, which is our only other place. Let's use ls. And so we have some things in here. Again, none of that looks terribly interesting. Maybe so a PNG is exactly that, a PNG. The AT3 is A-Track 3. That's a sound compression format that Sony was pushing as an alternative to MP3. That really was only ever used by Sony. I don't know what this params SFO is. That's kind of interesting. So it gives us some more information what the title of the game is. And so I'm guessing that this is a well-known file that they can, the system can go to read particular things about the disk. Let's look at the hex dump for that. Because the order of the strings makes it appear like this isn't just strings. And it's not. There is some other data here. So it is a binary file. And these are the strings that we find in it. Okay, so Blue Harvey saying DRA is the game engine. When I say it's not really a game engine like we think of it today, it's not Unreal or anything like that. It is the game and all the Alucard related code. And things for loading than the stages. Stages themselves are what have the enemy sprites and enemy logic in them, which is why it's difficult to move enemies to different places. So yeah, when I say game engine, it knows a lot about what each of the stages can do. It is not portable. You can't make another game very easily with the code that's in DRA, but it is kind of a centralized place for common functions. Yeah, did game engines exist? There was a few, like, what was the LucasArts one? And Sierra had one as well. Oh, drat, why can't I think of Scum VM? There was a few around that time, but yeah, not common, because the overhead of having a game engine was pretty significant, especially for consoles at the time. So it wasn't necessarily practical. PsyQ is interesting. Well, SDK-wise, looking at that compared to Sega Genesis and Sega CD stuff is a huge step up. And I'll save that discussion for another day. So anyway, nothing in this PSP game directory. So the next place I think is worth looking is Sister. And again, we can't hex dump the directory. We could, but there's not a real reason to. So the update, I'm guessing, is like, what is the latest version of PSP? And let's load that if basically to support our DRM. But then we have boot and e-boot. And what is the difference between these? I don't know. Is there a difference between them? Let's see. Yeah, they are different. They were built a day apart. Let's look at those. I don't think that this is going to be what we're looking for, but these are going to be ELF files. And so that means we can use read ELF. Let's get that back. And let's look at everything. We can get an idea of what's in here. And this will give us any symbols that are exported, which might actually have a lot of stuff. Hey, Aldrich, good to have you back. I mean, what's nice about the Eldritch is saying consoles had a lot of different stuff, and now they're now it seems like, especially like on the indie dev side, you target whatever game engine you're choosing, and then hope that it has the ability to export for each of the systems that you want to target. But yeah, I mean, people were programming against the SDKs directly back then. But what's nice about the PlayStation, and my assumption is that this crossed over to the PSP and PS2, PS3 as well, was that they had a basically a POSIX compatible libc. And so if you think in those terms, like I do, it becomes a pretty familiar environment. So what are we looking at here? We have different sections. We're going to be particularly interested in the text section, which is where the program is. And what I want to see is what symbols are here, and are any of those relevant? And golly, they scrubbed this. Good, there are no exported symbols. Boo. So what would happen here is there are program bits. The 60 bytes at the start is probably a MetroWorks header, is my guess. So skip the first 60 bits and then just start executing the code that you find there. The SCE stub, that sounds like Sony Computer Entertainment. So probably something related to that. We might be able to get data and comments. And so what we see on the PlayStation, the entry point was something that was compiled by Konami. and main is the same function that most programs start with. They wrote that, Konami wrote that, and it probably is a template effectively that came from Sony and the SDK, but it was controlled by them. How the game started basically took over the entire system. It could call into BIOS, but BIOS didn't really have control over what happened. Here we're going to see something slightly different on the PSP where the operating system can continue to run. The comment section is a little interesting, a little small, 34 bytes, probably nothing too interesting there. Maybe not. What else might be interesting here? So what I want to do, since the ELF information didn't provide a lot, I want to look for some reference here, and we could do that with strings maybe. Some reference to ps.bin or dra.bin. Let's do that. And like I said, I don't know the difference between boot and eboot on the PSP. So these are all the ASCII looking things that are in this file. And so I'm going to look for first ps.bin. And I don't see anything. We'll probably or possibly get a bunch of the libc. Do you see anything like sprintf? No? Printf? So there are a few of the libc functions in here. Okay, so but why would they put both of those on the UMD? I agree. So somewhere in here, though, is logic for loading the next thing. So I want to find where that is. The next thing, I believe, is ps.bin. Yes, true. It didn't. You're right. And that's probably where I'm getting mixed up. So you either loaded the PS1 ISO from the eShop, whatever the Sony shop was, or you loaded the UMD, which is not Symphony of the Night, it's Dracula X Chronicles, which then is able to load Symphony of the Night. Good point. So I think Dracula X Chronicles is this ps.bin. I think that is the entry point, but I'm not sure. So I'm gonna look there. That's in, oh, I do want to stay up at this level. The only reference to that though is ps.elf, and possibly this is a this is hard-coded by the BIOS as well. Maybe not. Take out the AT3. So we data in eBoot. We don't need that. Let's force standard error. I want some indication that that is being loaded. Yeah, so the physical copy is the Dracula X Chronicles, where you have to unlock it and then access it that way. It's not, it doesn't boot directly into Soden. So we have a reference to DRA in main.exe. My assumption is that this is not ever actually used. So this is a little better, but where is PCE Elf being loaded? So if you're just joining, we finished Doppleganger, and now I'm searching for something new, which is where is the main equivalent? And this is perfect. Okay, so PCE Elf is referenced in boot.bin. Let's go back to that, see if we can find what that looks like exactly. Oh, why didn't PS Elf show up here? So we're referencing these 3 files. So it's possible that boot.bin is the menu system at the beginning. Yeah, so when you say the multiplayer server, a few months ago, I was talking with Family Jewels, and he mentioned a multiplayer, multi-game, like online thing where you can play different games with people, and things that happen in your game can cause other things to happen in their game. And one of the DS or Advance Castlevanias is in there. We might be getting to a place where we could do something with this as well. All right, so I had a feeling that of these 3, that PS.Elf is the one that I'm primarily interested in. Let's look at that and see if we can use read elf. Let's start with strings. Something like CD control. No, actually, let me look for that as well. That would actually be... that's what I'm looking for, is where are the CD control equivalents? And do we have symbol names for them anywhere? Things like... the math functions would be good to look at as well. Actually, that's maybe should be what I do, is go through and look for some of the SDK functions that I know are being called. Look for... there might be an error related to PolyGT4. No. They all have something related to GT4. Nothing interesting. This begin. Where was that? No. What am I looking for? Let's look in DRA. See if there's anything that looks like something that I would want. The CD callbacks, possibly. How many buttons does the GameCom version have? Can you give a negative ranking to the mobile versions? for control scheme. Like playing the Tiger handheld is more playable than the mobile versions. Okay, so I'm gonna look for something where I know has PSP code in it. And also a CD function. CD function? Best thing to look for? Yeah, sure. CD sound command. Ultimately, these are going to go back to BIOS functions. Like this. Okay, and I doubt that... Oh, that's what I should be doing as well. There's one more thing that I should be looking at. Come on, you can do it. There we go. Okay, so this is a function that I know is implemented, but it's likely that the symbols are stripped. So we don't have that. The other thing that I wanted to look at was we know addresses of some of the functions, and so I could look for the address space. So I'm going to do that next. We do want user res ps. Let's look at ps.elf, and I'll use readelf for that. Have some warnings. And so what I want to look at is where does this think that it is going to be loaded in memory? And it's actually at the 8900 address, which is around where I want to look at. Yeah, playing on with a controller would be fine. I'm just talking about the screen controls. I think I've mentioned this before. I played through the PSP version on a Vita, and then I played through... That was my first experience with Soten. About 10 years ago at this point. And then played through it again. I found a PSP Go for a good price, and I played through it again on there. And didn't realize that the PSP control scheme was different. And the first time I played through the PlayStation version and couldn't transform. Is it Mist that has that you press both shoulder buttons? Couldn't transform into Mist. Okay, so we have a lot of references. So I do think this may or may not be something we want to look at. Okay, so what I want to do though is I want to find the main entry point. We don't have symbols, but we are loading this at 8900. So I want to find some of the functions that we know are in 8900. I'll probably go over here and do that. So let's look at PSP EU DRA. Why do I want to do this? Because I feel like if we find Konami's PlayStation Bridge implementation, all kinds of fun things can happen. Is that true? I don't know. That's my working theory. And here it is, load clut. This is what sent me on this journey this morning. Load color lookup table. This is a PS1 SDK function. And here is our address for it. Is this address is in the address space of this ELF file. I think we have it. So I'm going to take this address, put it in my calculator. This is so epic that I'm gonna share with you all. There's my calculator. Okay, so here's our starting address. Our size is 80830. The mem size is interesting, but I don't think I'm concerned with that. That could be showing that everything after 830, we have to zero that out. I'm going to add those together. So we have 8980.830. Right. Keep that. Come on. And then where is our load clut function? 891cc. So that is in this address space, which is what I'm looking for. So I think that this is the equivalent of main on the PSP. What I don't know, so we don't have symbols, which is fine. So I don't know yet. What don't I know? I don't know if what we're going to find, is it something that was provided by Sony, or is it something provided by Konami? And what I want it to be is Konami code that's re-implementing the PlayStation SDK. If that's it, I'll be happy. Die happy, man. I could be done with this project. No, I'm kidding. I'm going. Don't you know the clut is a myth? Or something like that. Color lookup table. Oh, I'm back. So now we're going to do something that I don't know how it's going to go, and we're going to start a new splat file from scratch, because we really can't rely on any of the tooling that we have. So I'm going to call this SPU. I don't know if anybody wants this either. I didn't talk to anybody about this before doing it. Does anybody on the Soten Decomp project, does anybody care about this but me? Who knows? I don't. I'm going to call it PS. I know it's not a great name, but that is what this file is called. And we're going to start basically from scratch writing a splat config. Because I can't do that from memory, I am going to look at the PlayStation main, the US main YAML. This is, and I probably need another one that I'll load off screen. I'll need a PSP version of this as well. Is any of this going to work? I have no idea. Should I have done this on my own time? Not dragged you all into this, probably. But I'm flailing because I don't have Doppleganger anymore. So we're going to start with our options. This is a YAML file, so it has to be YAML-y. Yes, it is hex. I'm gonna do your thing. I think I know what number this is gonna be, and if so, I'll be amused. But Shoot, that wasn't what I wanted. Let's try it again. Oh, plus, let me do it again. That is that is the joke. I appreciate it. I've taught my kids to spell things on calculators, and they haven't figured that one out yet. Much to my... What? Is that good, bad? Should I appreciate that they're innocent, or be upset that they are not that immature? Alright, so we're going to call this PS. I encourage everybody to follow Project Omega's instructions for your own enjoyment. So I'll kind of walk through what is happening here and go over. This is kind of a good Splat overview as well. So Splat is used for taking the binary files that we have, splitting them up into their different parts. It actually can help pretty well finding where different offsets are, but fortunately this is an ELF file, and ELF files, we get a lot of those offsets anyway. And then also provides linker scripts for taking all those parts and converting them back into the binary file that we wanted. Only the oldest is old enough for a TI-84. And he's not figured out how to graph things yet. No, I shouldn't say. He absolutely knows how to graph things. He hasn't figured out how to graph things that his teachers might not like. So we set up our configuration here. There's going to be actually a reasonable amount of configuration. We're going to tell Splat that this is PSP. Splat tells SPIM, which is the disassembler, that this is PSP. SPIM tells Rabbitizer, which is a MIPS instruction parser, either that this is PSP or the specific MIPS family, which is Allegrex, which is only used in the PSP. Our target path, this is the binary that we are looking for, which is this guy here. The ASM path, this is where we want the ASM, the assembly, to be emitted. We always use the PSP EU prefix for that, and we'll call this PSP. Asset path, I don't know if there's going to end up being assets here. We'll define it anyway, and we'll call this PS. It doesn't conflict with anything that's in the PlayStation or any other systems that we're doing it, so that should be fine. The source path is going to be source. We'll use PS. Sometimes for something like PSP overlays that we haven't matched completely yet, especially the ones that have code that is different from the PlayStation version, we'll usually leave this one directory up, and then in each of the segments specify either the directory for that overlay or a PSP specific one. In this case, there is nothing but a PSP specific one, so I don't think that needs to change either. Our LD script path is going to be build PSP ps.ld. Our compiler, ooh, this is interesting. What is our compiler? I'm going to look at, I don't know. let's look at sen, DAI. What? Give me one of these. NO4. Okay, so they all specify GCC as the compiler, even though I'm pretty sure it's going to be MetroWorks, but I'm going to go with what we have in our other ones. Our symbols adders. And this is one of the reasons that I want to do this, is to get some of these symbols resolved. So we have our symbols for the PSP EU. These are symbols that are shared across overlays. Often these are things that are going to be defined in this ps.elf, but also in DRA, which has things that all the other overlays use. And then we're going to have one specific that's private to this overlay as well. And treat gravity well. You missed my confusion of Hungarian and Polish earlier. Yeah, I never understood Polish calculators either. I said Polish notation when I meant Hungarian notation, but it comes full circle. Now we have RPN back in the stream. What do we want to call our undefined functions, or where do we want those undefined functions to live? We're going to put them in undefined funcs auto PSPEU yes text. And where do we want undefined symbols to live? These are things I call them automatic. Splat calls them undefined. So these are, these are symbols that we don't know yet. They're not defined in code. They're not defined in one of the symbol tables that we included above. And I'm following the convention of all the other overlays on this project. Find file boundaries. This is nice. This is something that Splat does. As it's going through, it'll look for things that are normally aligned at certain addresses, and if they're not aligned at those addresses, it's likely a new file that just got shoved right up against all the bits from a previous file. That's what that option does. Use legacy include ASM. I don't think we need to set this. I think it's default now. I can't tell you what it does specifically, but there was a macro for including ASM, and that changed at some point. And so if you want the support for the old macro, you can do that. Migrate RO data to functions. This is nice. This is what moves symbol tables into the same ASM file. What do we want to call jump tables? The convention is to use JLabel. I don't know why. Why can't we use the default? I don't know. That's the convention, so I'll stick to it. We want to call symbols PSP VRAM. So when a new symbol gets made, it's going to have its own prefix. If it is data, it'll have a D underscore. If it's a function, it'll have func underscore, followed by PSP, and then followed by the address. We want to put non-matchings. Do we care? Non-matchings path is going to be PSP. This is what DRA does. I don't think that that's necessary here, so I'm going to get rid of it. Disassemble all true. That means even if we have functions that are matching and we don't need the assembly for them, it's still going to generate the assembly and put it in a matchings directory, which is nice. The non-matchings, do we need a non-matching? No, I don't think we do. Section order. So these are the each of the different sections that are in the file. What order do they come in? My guess is that these are the same as the other ones, but we do have some things here that are a little different that I don't necessarily think that we're going to have in the other overlays, because this is like a true and proper ELF file, whereas overlays are often just the functions necessary to run and their associated data. And you can't query the file or find tables in the file that tell you where all the things are. They're not dynamically loaded. They're just forcibly pushed into RAM and then used from there. If they were ELF files, relocating things would be much easier, but they're not dynamically loaded like that. But this one is. And so do we need to worry about that? I don't know. So I'm going to take a flyer and make some assumptions here. And I'm going to say that some of this, so we know things like the MetroWorks header gets put in at the beginning of the PSP overlays. It looks like there is a string table that is getting put there. I don't know if those sections actually, let's look at that. Let's go to the Splat. GitHub repo. They have a wiki that tells us what sections are supported. And we'll see what there actually may be a all right, section order. But do we get a list of sections? Let's look at advanced maybe. Nope. All right, here we go. Segment types. Okay, so here's what we have. So the string table at the beginning might have to be treated specially. We don't have a exception table. So what the string table is going to do is basically, it is a table of strings, as you might expect. And then there are references to that table other places. So you might have like a debug symbols table. The debug symbols aren't going to include the name of the function, for example. They're going to include a string table index, and then you have to go back to that string table. Is there anything like that, though, here? There isn't. So I'm going to skip it. I guess what we are able to do is Splat will allow us to skip the sections that we don't want. So we start with prog bits, and that is the same as text. And that's primarily what we're interested here. And we have a bunch of other text here. It looks like library stuff as well. So this all might be code that we're able to extract. We'll see. Rel, I don't remember what rel is. Somebody might be, oh, relocation table. So then we have RO data. So after text, we'll have an RO data section. It's a little different from the other ones. Then we have a data section following. And I'm just looking at this this column here. What are these being called? They can be given effectively whatever name they want. Usually when you're going through these, you're looking at other pieces of this. And then we have BSS. And what's interesting here is we do have references to DRA bin. But the size of these I wonder if these are getting loaded dynamically as part of the loader. We'll see. We'll see how that works. All right, we had data and then we had BSS, and now we have these other references to all of the other bins that are going to be referenced. And this is just a guess. My guess is that these references are built in at runtime or at build time, which could be wrong. And then they can let the loader either dynamically load those or something else, but we'll see. So our next section was BSS. BSS is uninitialized data. So let's go back up to the top. And now I want a few of these offsets. LD BSS is no load. That's interesting. Sorry, just seeing another option that I've seen before. LD BSS is no load. I don't know if that's true or false, but we'll go with true. Disassemb unknown. Sure. Global VRAM start is... Oh, I gotta get these right. I'm gonna just copy pasta. And then what does our assembly file header look like? I'm going to copy pasta that as well. So this will be set at the beginning of any of the assembly files that get generated. We include a SHA of that file. And that's so Splat knows that it's getting the right file, so we'll calculate that. SHA-sum or SHA-1-sum? Not file. Oh, come on, come on. And now we come to segments. And this is how we're going to break up the files. We start at 0. We're going to say that 0 is a bin. We don't know what it is yet. Well, we do know what it is, sorry. It is a string table, but we can't do anything about it. So we're just not going to touch it. I'm going to call it strings. I'll call it string table. And we're going to ignore it and hope that it doesn't come back to bite us later. So then we have the one that we're interested in. This is hopefully our code. We'll see if this works out. Its start is at I was wrong. The string table does not come first. What does come first? I don't know, but our program doesn't start until offset 16F4. So we will start there. Our VRAM for this is Mozilla was on the the chat the other day, and ESS size. We'll come back to that. You mentioned VRAM being the video RAM for the PlayStation. I always think of VRAM in terms of splat and not the video RAM. Alignment. Does I don't see a specific alignment. I have gone through, though, Allegrex. DRA is aligned at 128 bytes with a sub-alignment of... Sub-alignment is what I was thinking, of 8 bytes. I'm going to stick with that. And now we're at the sub-segments. We don't know what any of these are yet. And that's hopefully what Splat is going to tell us. Sub-segments. Make sure I spell it correctly. We added spelling. Our start is going to be at this 16F4. We're going to say that it's C. And we're just going to call it PS. How long does this go? Oh, we actually have another segment, and maybe I'll add this one as well. So we know about these others that get loaded later. I'm going to try to ignore them. Can I do that? Yes, I can, because... Oh, what's the best way to do this? BSS size, we're just going to say 0. Because actually we only have C here. And what would be nice is if all these other ones just went away. No, that's too bad. I didn't spend any more time on it. So Mozzilla's saying there's still a bug with the Maria mod for PS1. There's actually a funny comment that was posted in Discord from Dragon Blitz's DB Daily on that, about how this wasn't special, that they remember playing as Maria using the Game Shark on their PS1. That'd be a heck of a Game Shark code. But yeah, sorry, I haven't looked at it anymore either. What is the best way to do this? So sometimes we have multiple segments that are built in, like weapons is this way. They each have their own text. They each have their own data, RO, data, BSS, and they're just consecutively in the same file. And that's not what we have here. We have a regular plain old ELF file with a bunch of different things. And what I want to do, I guess, is find where RO data starts, which is here. And that's how I'll treat it. This can always change, I guess, as and should we call this specifically what it is? It's getting cut off, but it's something from Sony, it looks like. Another RO data segment. These aren't in order, are they? Well, that's gonna bite me as well. I will name this, I guess. We'll call it that. Oh, the B274 is not right. I'm gonna just keep all of the RO data together. I've never done this with a ELF file before, so I'm not actually sure what I'm doing. Believe it or not. You probably believed it, but data starts at offset 3C. I mean, those values look reasonable. We'll see what happens. I do know some addresses into this, and so if we get to the point where functions are being exported, then... Oh, that's what's happening. It's setting up the offsets. Oh, this is sweet. This is what we don't have on the PSP side. We just have to have symbols for these at the different offsets. So it's saying when you load DR... I think this is what it's saying. When you load DRA.bin, load it at this particular address. And if we look at DRA.bin, is that where it's being loaded? No, of course not. Why would it be? Actually, I'm wrong. It is loaded there because the first 80 bytes are skipped. This is actually 80 hex. 80 hex earlier than DRA.bin is loaded, and then that is the address for DRA.bin. Great, that's perfect. So what I would expect is this cell offset or address, yeah, to be repeated for every stage. So, oh, this is exciting. So these symbols are loaded in this PS ELF file, and then they're going to be exported to, I think, to DRA.bin, and that's how it's going to get these addresses. That's cool. That doesn't exist on the PlayStation version. Neat. Okay. And so Maria bin, I would guess that this is 80 bytes off as well. Look at that. Sorry, I have this. I have this open in another window, so I see these addresses, but I'm not showing you. We look at PSP. Maria. So, where was Maria here? It says load that at 6200. Where are we loading at? We're actually loading at 6280. That's because the MetroWorks header takes up 80 bytes, or 80 hex bytes. 128 bytes. Sweet. All right, so I think that this is enough to do something dangerous. Probably broken in a lot of different ways. Took us a long time to get here. So I'm going to use split this file. All kinds of errors. So I probably need to do a YAML lint on this first. Do I have anything? Do I have anything that will read a YAML for me and tell me where I'm wrong? I'll do this. I'll look for something online. It is a bummer. I have a love-hate relationship with YAML. It's valid YAML. So there's something else I have wrong. Let's see what that might be. Oh, unrecognized YAML options, symbols, adders path. That they didn't need to put a huge stack trace. because it's not symbols, it's symbol. Oops, not PB copy. Let's try it again. File boundaries. Find file boundaries. That's what happens when you don't copy paste code. Okay, so we started. Func sim is not none. That's a start. So we have a segment type. Okay, so we're getting into something that I was a little worried about, which is not knowing what some of these other segments are. And so what I'm going to do, what we will do is end this at I think the next offset is this B2, B74. And I'll just say everything after that is bin. And hopefully that will work. Is that the next smallest offset? Let's try that. Actually, how big is our text? Is 39D08. I'll just add the offset. Go back to the calculator. 39D08. Gives me 3B, 3FC. Do you have anything else at that offset? We do. 3B, 3FC is, that's also a C file. That's going to be a C stub, whatever that is. And how long is that? So we'll take that plus 5F8. And do we have that? So basically, we just need to tell Splat about all these things. We do have that as well. This looks like the address for the library, maybe? Or no, it's a library entry. So I'm going to say that's a bin. We could also say that's RO data. Let's try that. Let's see if that works any better. No, still not. Let's see if we got anything from that. No, it didn't pull anything out. I guess we'll have to look at what this code is doing and why it's not happening. No, I don't want that. And we're at line 433. Sometimes I find the splat code to be intractable. So there's definitely is a possibility that I will not be able to interpret this error. So it thinks we're at a function, but there is no symbol related to this function. Oh, I've run into this error before, and I think this is just a issue in messaging. We don't have the symbol table yet. Let's try it again. Nope, same thing. I've had that issue before where if the symbol table doesn't exist, Splat fails. But this doesn't seem like a problem. I was really hoping to have something here. Okay, so what else can we do? How can we make any progress at all? What I think I'm going to do, and this is a hack just to see if I can get anything out of this, is not too far after this, I'm going to add a RO data segment, even though I think that the SC stub is functions. I am going to make that RO data as well. I just want to see if any of this is getting pulled in. It's not. Drat. What a bummer. Is it possible that there's a MetroWorks header here to deal with as well? And we need to be 80 bytes later. Fortunately, I don't think readelf. Oh, it has. We might be able to get a disassembly for this from readelf. Let's try that. And that might tell us a little more. I never remember what that option is, so we're gonna look at help. Okay. Oh, maybe that's object dump. I'm thinking. Yeah, object dump will have disassembly. So let's see that. We're gonna try object dump with X for everything, disassemble all. I don't know how other people do. I've not seen other people's process for bootstrapping something like this. Oh, there we go. That was a lot. So it looks like this goes to 3BBA4. That's what I'm getting out of that. 3BBA4, yeah. That's where I thought RO data ended, and that looks like it is correct. So let's do this. We don't need those. Our start address is here. So this should be our main at this address. So let's see if we can find that function. And that does look like the start of a function. Right behind it, we have the end of another function. So I'm assuming that 8397774 is main. We could add that to the symbol table as our start address. Let's see what else object dump is going to give us. Yeah, so we were getting the right stuff from we're getting good stuff from readelf sc module info. So some of that we may want to pull into VS stuff. I wonder if that's a reference to Visual Studio or not. But they would Visual Studio have been used, or is it just GCC and MetroWorks? VSS at AEF24, that's right. Data at 3C520, that's good as well. And then we have these other symbols in there. No real symbols, though, just segments. So code does start right away at 890,000 hex. So we know we have a function there. This doesn't tell us or go back to what the offset was in the file, which is kind of a bummer, but we would be able to compute that if necessary. But then we had our entry point. So I'm going to add a symbol for this. I don't know if it's going to matter. I do need to figure out what Splat is upset about. Nope. And let's try again. One thing I might want to look at is, I don't think it's going to matter though. I was going to look at, so Patapon is in progress. These are the only two PSP decomp projects that I'm aware of. I want to look at, just out of curiosity, main, and see if there's anything funny here. So they do a 800 or a section at the beginning that they call header. And nothing too crazy. Let's try it again and see. No. So I'm going to have to add probably some debug text. This is my preferred way. I'm sure there's a Python debugger. We have Go, Python, Rust, C, Make, Script, all this, lots of different languages, lots of different tools. I don't know the debuggers for all of them. I haven't done Python prior to this project. And don't do a lot of Python in this project, so I'm not familiar with that. So I use good old-fashioned print debugging, which always works, regardless of the language. Good skill to have. You don't know the tools. That looks like the only information I don't know what's in the function struct or even the entry struct. So let's add another line. We'll just print out the entire entry and see if these look like values that look familiar. One, two, ready, let's go. Oh, and what did I do? Did I break something? Looks like I broke this. So we should have our VRAM entry. I should have formatted this as hex, but I didn't. We don't have any symbols, so this is basically right away. Let me translate this VRAM address from decimal. Would have been nice if I'd have printed this in hex. This is right away. This is the first address. That's here. Global segment has its VROM start equal to the VROM end. So that seems like a mistake. Oh yes, I know what the issue is. Duh. Sorry. My bad. I need one more entry here, and that entry should be the size of the file. So let's do that. And I'll convert that to hex. So a lot of screw up. There's something pretty easy to fix. Let's do it again. Now what does it not like? There's an error. Wow. Oh. Oh my goodness. This is what's fun about this stream is I fail, and then looks like hour and 45 minutes in today, I succeed at something, and we should have a ps.c here. We do. What's in ps.c? Nobody knows. Let's split and see. All these functions, one of them should be called main. It is called main. Why does it have an underscore at the end? And we have other symbols because we know what those symbols are. Oh my goodness. Oh my goodness. This is exciting. Okay, so I'm going to tell you why I'm excited about this again, even though it may seem stupid, it may seem silly. I look at all those empty functions. I think, I'm not sure, but I think that this will pay dividends for the Xbox 360 decomp, should that ever come. But if nothing else, this is possibly an alternate implementation of the PS1 SDK. We have at least 2 side projects. We have at least 2 side projects which are decomps specifically of the PS1 SDK, and another side project which is a re-implementation of the PS1 SDK to link decomps against system libraries for easy porting. And so having another implementation of the PS1 SDK possibly that wasn't written by Sony is kind of a cool thing. So geeking out a little bit, let's find something that's not a function. This is a perfect one, actually. A really nice function like abs. Abs is a built-in on in GCC, but it is a real function in, I'm glowing. This is so stupid, but it's something I'm very excited about. It is a real function on the PSP version, and let's look at the assembly. So first, we're going to get our first decomp. Oh, we have all kinds of things to figure out, though. All kinds of things. What do we have to figure out? We have to figure out what the compiler is. We have to figure out what the optimization level is. So we're not out of the woods yet. This is just beginning. So we are going to go to the PSP. We will use the Symphony Night preset. An unrecognized opcode max. Okay. So I'm not sure if this is a pseudo instruction or an Allegrix specific instruction. Let's go to... where was my tab with... I think there'll be a link to Rabbitizer here. Oh, there should be. I don't think Rabbitizer is part of AthTech. I think it's part of Decomp. Decompilators? Elaborate? No. Map file parser will have a link to Rabbitizer. I could just look for it too. Map file parser is sweet. I had written a map file parser in both Python and Rust, and then I found this project, and it is awesome. Oh, why would it though? Let's just, I should have Rabbitizer somewhere in here. Oh, come on. It was part of Decomp Elaborate. Decomp Elaborate? Collaborate while decomping. So what I want to look here is for max. Is the max instruction. Um, 83 file. So we want to look for something related to Allegrix. So it looks like the 5900 has the max instruction. So Rabbitizer looks like it knows what that instruction is. Let's look for that max underscore s. I assume that anything Rabbitizer would know. Oh, it doesn't. maybe? Knows Vmax. I assumed everything that Rabbitizer knew, decomp.me would know as well. What I'm trying to figure out is there another instruction that we can use instead? And unfortunately, there's not a lot of documentation readily available, like easily searchable for that. Let's try switching it to Vmax and see. No. All right, let's see what. Let's try a. I just want to see if anything will read the max instruction. I need something with a 5900 in it, and I might not have that. Is the issue, and this is a little Indian anyway. So we might be at an impasse for this one. Bummer. All right, let's switch over. Find another one. I was excited about that one, but can't win them all. Winning too much today. Let's find something else. I think that this is a variant of abs. We could look at that one as well. And do my changes here since it was my own dumb fault. It would be nice to have a slightly better error message there, but beggars can't be choosers. It's the same thing. Memcopy, that's a good one. Look at memcopy. So, memcopy might not be solved, actually, for PS1 SDK. But maybe we could solve it here. The other thing this... delete this. Wrong system. Excuse me. Okay, so we have an M2C error. We could fix that relatively easily. We'll get rid of the mcopy declaration. Try to decompile again. Read from unset register T2. That's a bummer. So M2C is not going to help us. Thanks, M2C. I'm going to check if we have a memcopy implementation. No, and this is tricky. I've worked on this for a long time. Let's look at what I had and how close I was. We have a PS2 memcopy. Let's take that. Memcopy 2. No, I want my memcopy. Is there a way to get my memcopy? I don't know if there is. Drat. Actually, I do know how to get my memcopy. We'll go to so in decomp. Go to the wiki. In the wiki, we have functions that have been started. And I think I have the closest match. Oh, it's not here. Bummer. It looks like my sprint F is, but that's not good enough. I really thought I had a mem copy. Oh, striking out. Oh, maybe this is the whole thing. Let's look at the raw. Here's the whole thing. No, it is the whole thing. Okay, we can do. We can find the PS1 mem copy, and I'll do a okay implementation of mem copy. It's kind of funny that these small functions become so difficult, but they're tricky. What this is, that's the wrong one. Oh no, we do have mem copy. Let's go. Oh, drat. It's just a BIOS function. Drat. Okay. Keep going. Let's do a mem copy implementation and see how close we get. I don't know what this is making another call, which is odd. I wouldn't expect memcopy to do anything like that. Oh, there's a branch. That's why it's failing. Let's get the prereqs. It looks like we have RO data that is missing. Possibly. No. Oh, this ends up being... It's like a function comes in right in the middle. So there's something funny. This should be just a label. So let me rewrite this, and then we'll go from there. So I'm gonna give this just a... Now my fake label, and I think that should be enough. So for whatever reason, it seems like something may be branching into this mem copy. Maybe it's an inline function. That could be. We have all that to deal with, possibly. But we'll try this and see if it's any better. There definitely is going to be things that may be different. Still upset about that register, so possibly wasn't related. Yeah, so we're not going to get a new one. I was hoping to get something done, but we'll find something. Rand and SRAND. We try that. Nothing funny there. Famous last words. Yeah, no problem, Blue Harvey. Thanks for joining. Really appreciate it. Thanks for chatting as well. It's always fun. Have a good night. Let's get one of these in place. Come on, come on. Okay, so we're mostly here. Looks like maybe no args for this function. Temp S0. We'll say it's an unsigned 8. And then here we'll just grab offset A8 and offset AC. I don't know what these are. We have more of these. We're setting these values. My guess is that this might be like a PRNG, but I don't know. The generated code's not anywhere close, and that could be for a lot of reasons. I'm going to assume that we do have optimizations on, so let's go with O2 and see if that helps. It could be even higher than that. It could be O3, O4. That is going to be somewhat difficult to determine. We may have inlining options as well. Let's do O4S and see how that works. O2S. Probably have to go through each of these kind of individually and see what might be happening here. So let's start there and see what might be going on. This temp S0 versus V0 doesn't seem to make sense. These are coming back as an unsigned 32. So we need to divide these by 4. And the same thing down here. Yeah, so what I think I would probably do is look up these magic numbers. It does seem like this is a PRNG. And we may be able to find, so my guess is those are large primes. Do a quick search for those. Yeah, so I do see these in a bunch of PRNGs, so it looks like they're well-known values. Here is actually, this one might be interesting. Yeah. I was hoping they had this decompiled. So there is a another version of Rand. And where is this? This is Sigwin's. I shouldn't be looking at this, but I'm going to. This is Sigwin's Rand implementation. We need the check Rand. So I always wonder whether or not, it looks like, yeah, this may be, maybe this is just the art of computer science implementation. I will have to come back and look at this later, but it probably would be good to, I don't have a copy of The Art of Computer Programming Volume 2, but it probably would be good to look at that as well and see what that implementation looks like. But my guess is some of this has to do with overflow. I don't know if there's a proper 64-bit multiplication here. So some other things, but it is a Rand implementation. Rand is normally a BIOS function, I believe. I'm confirming that. Ultimately what I'd like to see is, yeah, it's a BIOS function on the PS1. But now we have an implementation. So we're going to have an implementation of a lot of these BIOS functions, which is also awesome. I'm going to go over here. I have to get going, but I would like to find one of these that this looks like something that is not too fancy and looks like it may just be calling a Rand variant. Let's try that. If we can find something simple, we can determine compiler settings, which is something else that's going to have to be done for this. So we have this unknown 8A and unknown 8C, and we know what those were. Those were 2A. And my guess is that this is a struct that would have to be defined. And we'll just say this is S32 for now. And then going through, trying to figure out the optimization level. This is a pretty simple function, so it really depends on, do we have these arguments right? Are these assignments happening at the same time? Let's try a few more of these. See if we can find something that's going to match. There's not a lot of code here. I don't think that this is going to be no optimization. Oh, that would be incredible, but I doubt that's what we're going to see. We do, it looks like, have a second variable. I'm just going to call it high. And again, kind of come through and see if we can figure out what this might be. That one's very close. O2. We're missing a move. That may be due to a static. We're moving arg0 into S0, but why? Maybe another variable? I would think that that would be... Yeah, I'm gonna have to poke around at this a little bit more, but we're pulling functions and those functions look reasonable, which I'm happy about. If we can find one that we already have the implementation for, maybe we can find something. So that's it. I'm glad that we got to where we did. If you're tuning in late, what I wanted to do was find where main was. Actually, that I can't stop myself. That is one more thing I want to look at. This is main. And what does main look like? A bunch of M2C errors. Okay, so we're not seeing anything there, unfortunately. We'll have to come back to this later when I learn more. I'll be here Monday next week, and then taking the rest of the week off. If you're not familiar with the Castlevania Symphony of the Night decompilation project, go to soten.z.dev and learn more. Thank you, Modzilla Eldritch, Project Omega, Blue Harvey, Dig Down Deep, Entropy Gravity Well, and hopefully I didn't miss anything. Anybody who showed up in chat, always appreciate everybody here in chat. And I'll see you next week. Maybe I'll have some news about this. Adios. Wrong button.